So our objective today was to review asexual and sexual reproduction, which we have with the gallery walk, and learn how long-term and short-term changes affect the environment. So our essential question is, how are long-term and short-term changes different and similar? And how would they impact the energy pyramid of an ecosystem? So everybody should have that essential question on the top of page 105. So we've been talking about ecology, and we've talked about how organisms are able to live in a stable ecosystem. And for the most part, all ecosystems are going to be stable, okay? Because they want to reach that stability. They're going to grow, they're going to have enough biodiversity to keep that ecosystem stable. But unfortunately, things aren't perfect. Things occur, changes occur in the environment, and that causes long-term and short-term changes. So what we're going to look at is we're going to look at similarities and differences between short-term and long-term. So you probably want to make a what? A T-chart, okay? Or a Venn diagram. So we're going to look at, did I do that? No. We're going to look at some long-term effects or long-term changes first. So, if we think of long-term effects or changes, when long-term effects or changes occur, what basically happens is that the ecosystem changes the stability of the environment. So that environment stability changes extremely because of these long-term changes. And the reason for it is because of the things that occur. So if we look at an environment or an ecosystem that has gone through a long-term change, the stability has changed. And because the stability has changed, a long-term change can cause basically irreversible changes, serious losses. So when you have a long-term change, you basically lose biodiversity. You lose a lot of organisms. And because you lose a lot of organisms, the stability is no longer there. It is an unstable system. Now, some examples. And guys, these are not a set list. These are just examples of things that cause a long-term change. Deforestation, urbanization, ice age, sun intensity, global warming, pollution. Those are things that will cause an ecosystem to change so much that it becomes unstable, and it may go back to what it was before, but it would take a long, long time to do so. And that's if it can go back. Because these long-term changes can change an ecosystem so much that it completely changes the environment. Yesterday, we talked about the pepper moth, right? Did it drastically change the environment in that area? The Industrial Revolution? Yes. The Industrial Revolution changed that area so much that it completely changed the ecosystem. It completely changed the populations. So, let's look at some of these examples because you need to know what they are. Deforestation, very easy. What is it? Cut down trees. So if I cut a bunch of trees out and there are no longer any trees, is that going to change the amount of insects, birds, and animals that live in that area?
Yeah.
Yes. Is that going to also change the plant life that's in that area? Yeah, because think about it. If I have all these forests, these very lush forests, that cover the sun, am I going to have a lot of plant life on the floor? No. Now, if I cut off all the trees, now can I have plant life on the floor? Yeah, because now sun is being able to get to that floor, to that forest floor. So it grows again. So what you're going to see is that deforestation can change in an area so much that it changes the organisms that live there. If there are no trees for those birds to have shelter, then there are going to be no birds. So with long-term effects, you have things that can change a ecosystem so long. That can change so long because how long does it take for a tree to grow? Hundreds of years. So that's a long-term change. Urbanization. What does that mean?
Humans like take over.
And build what?
Houses.
Houses, cities, right, basically. So you build cities, that's going to change the area, correct? This area right here, when thousands and thousands of years ago, this entire area didn't have these refineries, didn't have all these houses. Okay, so obviously the land changes, the different animals and organisms that live in it is going to change. Ice Age, what does that mean? It's covered in ice. Okay, are you going to have any tropical animals in this area anymore? No. Okay, sun intensity. Well, if there is a lot of sun, temperatures increase, right? Some organisms cannot live in very hot weather, so that will change. Sun intensity, if it decreases, temperatures would decrease. Animals that can't live in cold weather, or organisms that can live in cold weather, would not be able to survive. Global warming. It's usually because of pollution. So these two kind of go together, just because global warming occurs because of pollution. It occurs because there is a thicker layer of atmosphere in the air, and that thicker layer is due to, for the most part, to pollution. But when you have this thick layer out there, what's supposed to happen, if we didn't have that, what's supposed to happen is the sun's rays come in, okay? Yes, the ozone layer. It comes in, and it heats us up, and then it bounces on the floor, and then it goes out, and it's out, right? But whenever we increase the thickness of the ozone layer because of pollution, the sun rays come in, they bounce on the floor, they bounce back up, but instead of just going out into space, they hit that ozone layer and then they bounce back down. And then bounce back up and then bounce back down. So basically it's like you're in an oven because the heat isn't allowed to escape. Have you ever been in a greenhouse? Have you ever been to Galveston at the rainforest?
Yeah.
If you've ever been there, it's basically a glass pyramid. It's a greenhouse. Have you ever seen greenhouses? Their window panes are made out of glass. What those are for is to allow the sun to come in, but not allow it to go out, therefore it warms up. If you have a greenhouse, you're able to grow tropical plants. You're able to grow plants and roses and so on in the middle of the winter, even though it's cold, because it's trapping the heat inside, therefore allowing those plants to grow if they need that warm weather. That's basically what happens to the earth with global warming, is we have something called the greenhouse effect because of the fact that our ozone layer gets so thick, sun comes in, it's not allowed to leave, it stays in, so it heats us up like an oven. Yes?
The ozone layer is thick, why does something in?
Because we also have holes. So you also have to think about the fact that it's not thick, completely the same thickness all the way around. We have we have several holes in the ozone layer where it allows a lot of light to come in. Well, it doesn't just go in and then come straight back out. I mean, it gets dispersed. The energy is dispersed. Yes?
So how could the ozone layer become thin?
Why does it become thin?
How can it become thin?
Okay, so pollution can thicken it, and there's other pollution that can thin it. There are some chemicals that we put in the air that react with the ozone and basically take the ozone out, so it thins it, right? And then there's other areas where we're putting pollution in that just makes it thicker. So unfortunately, we're not doing one or the other, we're doing both things.
So we better build our ozone?
No, if there's no ozone, then we burn up. Yeah. So we need the ozone layer, But we don't need it too thin, and we don't need it too thick either. Yes?
So do other planets have ozone layer?
No planet in our solar system has an atmosphere that,
Just ours?
That helps it.
that would help it keep
Life.
these certain temperatures and certain light. Yeah. They do have atmospheres, some have ozone in them, some of them don't.
Venus has it.
But they're not perfect to the point of the perfection to us to be able to survive it. Okay, so any questions on here? Now, look at this list. A generalization, remember, is a sentence that kind of summarizes that, right? So generally, what causes long-term effects? Yes, us. For the most part, humans cause long-term effects. Right? I mean, look at these. We cause that, we cause that, we cause that, we cause that. These are the only two on here that we don't. Now, we can also put volcanoes in here, because some volcanoes, if they're very big, they can cause an extreme long-term effect. For example, I went to Italy. There is a volcano that erupted. It's called Pompeii, and have y'all heard of it?
Yeah.
Okay, so it basically destroyed an entire area. You can still go over there, and it's still destroyed. I mean, there's very few things growing in certain areas. So a volcano can also be long-term effects, but we're going to see that we can also include it in short-term effects depending on the eruption. Yes?
So what about like from the ashes from the volcano that it comes up the land? What about that?
Okay, ask the question again.
Like what about the ashes from the volcano that clear up the mainland? Is that also changing?
Yes, yes. Basically, you still go, and I mean, it's now covered in, like, it's caked on and things like that. But there still have areas where you can see that there's still ash there.
Like the one that was the Mount Sigurd, that big one, that I had like over the houses.
Yes, and that's going to change climate because all that ash goes up into the air, thickens it up. In that area, it doesn't allow sun to come in, so actually, what the first part of it is that it cools off. So that area cools off more than it should. Yes.
Isn't that an area that you still can see some people, like they're buried in, and you see
Yes,
faces?
yes. And you don't see the people anymore. They actually have castings because they want to preserve. So basically, you can go and there's like an area where they have, like there's one that's I guess very famous. It's a dog, and the dog was basically encased in the ash, and you can still see the bigger the dog, or you can still see the figure, the people that were basically just engulfed in ash and because of the eruption. All right. So an eruption can be a long-term effect if it's a big one. Okay. So any questions on long-term effects?
No.
All right, so now let's move on to short-term effects. So with short-term effects, what you have is you still have them affecting the ecosystem. So it's still affecting the ecosystem, but the ecosystem can function sort of normally. Okay? It can be changed. Organisms can die, but overall populations do not just completely go away, for the most part. So over a few or a short time, the ecosystems resist the change and they can recover fairly quickly. So the recovery here is very, very slow, if there's a recovery. The recovery over here is generally fast. Within a year, within a few years, you're going to have an ecosystem that looks basically exactly the same as it was before. Examples of this is drought, flood, smog, fire, frost. It could be a volcano also if it's a small eruption. Like there's eruptions in Hawaii all the time. But, I mean, nothing is completely destroyed. The ecosystem is pretty stable there. So, if you look at this one, generally, what causes a short-term effect? Natural disasters. Yeah, nature. So, nature is going to affect the environment. But because it's something natural that has occurred, over hundreds and hundreds of years, there's always natural disasters. An ecosystem is more likely to come back because the organisms are used to natural disasters. So if you end up having a drought, like we had that drought a few years ago that lasted a good amount of time, okay, it killed a lot of grasses and plant life, right? I mean, some of the areas were like barren. There's nothing there because all the grass died. Now you go to those areas, is the grass back? Yes. So when you talk about short-term effects, you're talking about something that can destroy an area, but because its short-term effects aren't that serious on the stability of the ecosystem will come back fairly quickly. Okay? So the major points is that you need to realize that long-term effects, for the most part, are caused by humans. Short-term effects, for the most part, are caused by nature. This one can come back fairly quickly. This one is going to take a long time, and that's if it's able to come back. Okay? So make sure that you also realize that some of these can be in both places, because smog is pollution, isn't it? Isn't smog pollution? So, and pollution is over here. But smog levels can increase and decrease. For example, Mexico is pretty polluted. There's a lot of cars, there's a lot of people, there's smog. Now, one of the things that they've done to try and decrease the smog is people can only drive their cars certain days of the week. So if you have a license plate that ends with an even number, they can only drive it on Mondays and Wednesdays and Saturdays or something like that. And I don't know the exact schedule.
Where's that
And then Mexico City.
at?
All right. So, but you have to pay double taxes and everything. So that's one way that they try to decrease the amount of smog because there's so many people there. I mean, it's the most populated, second most populated city in the world. So there's a lot of people. There's going to be a lot of smog. So that's one way that they've tried to decrease, and the smog level has decreased because it was getting really, really bad. I mean, it's still bad, but it's not as bad as it was. So even though smog is pollution, there are ways to decrease that, and the environment can always come back. Okay? Volcanoes can be here. If it's a very big eruption, it can completely destroy an area. If it's a small eruption, in Hawaii, the volcanoes are erupting all the time. The ecosystem is pretty stable, it doesn't get changed. Okay? So, any questions over those two? Now, the second part of our essential question is, how can that impact the energy pyramid? So, let's very quickly review what an energy pyramid is, because you should know it, and from what I could tell on your test, y'all remember most of this. So, ignore that pyramid right now. I want you to look. So you have this pyramid down here. At the bottom, you have your producers, your primary consumers, your secondary consumers. You could go tertiary consumers, quaternary consumers. You can continue on. Okay? So that pyramid shows movement of energy. Now, what is the original source of energy for that pyramid? Yes, I'm going to.
The sun.
The sun. Okay? The original source of energy is the sun. So, the producers are able to get as much sun or as much energy as they want because the sun's not going to say, oh, wait, can't get any more. The producers are there, they're going to get as much energy as they want. Okay? So, producers, which are autotrophs, make sure you know the word autotroph if you don't know it, basically make their own food. They take solar energy and transform it into chemical energy in the form of glucose. They make glucose, they make sugar. And that sugar has that chemical energy stored inside of it. So, The producers basically get 100% energy because they can get as much as they want. Then you have your primary consumers, which if they're eating producers, they have to be what type of consumer? Well, they're heterotrophs, but what type of heterotrophs? Herbivores, right? If they're only producers, they'd have to be herbivores, right? Or they could be omnivores, but let's just keep it simple, herbivores. So if they're herbivores, they're having to eat through those producers. Now, the producers get 100% of the energy, but they're going to use some of that energy. Actually, they're going to use most of that energy for their own life processes. So whenever those primary consumers, those herbivores, eat the producers, the producers, they don't get 100% of the energy. They only get 10% of that energy because the producers use 90 of it. So here I have 100% of the energy, the original energy that came into the system. Here I only have 10%. And yes, you need to know the percentages. Okay? So here I have 100. Now only 10% pass to the primary consumers. Only 10%, yes. Then the secondary consumers eat the primary consumers. So those could be your carnivores, or they could be omnivores. Okay? Well, the primary consumers got 10% of the original energy, right? But they themselves have to use some of that energy because they're trying to run away from these other ones. So they're going to use some of that energy and they're going to use most of it. So they use 90% of the 10%. So if they use 90% of the 10%, then only 1% comes up to the secondary consumer, right? So I had 100%, it went up to 10%, 1%, and then if there's another tertiary consumer here, these are going to have to use most of it also, right? And only 10% is going to get passed. So then I go to 0.1%. So what you need to realize with an energy pyramid is what's happening to the amount of energy available as you go up. It decreases. So make sure you have that in your notes. So energy, as it goes from the bottom to the top of this pyramid, it decreases. And it decreases because you're going to use it. If you think about it this way, if I have this big bag of candy and I come over here to Eric and I say, all right, Eric, you can take some, but you're going to have to share it. And he says, well, I'm only going to share 10%. So he takes 90% of the candy. Okay, passes it on to Ivan. Ivan says, well, he took 90% of that, I'm going to take 90% of that, and passes it on. Who's going to get the least amount of candy? The last person, if any, back there. Right? So that's basically what happens to the energy pyramid, or energy in this pyramid. So any questions on that? That's something review that you should already know. You do have to know the percentages. So remember it's 100, 10, 1, 0.1. If I kept going, it'd be 0.01. If I kept going, it'd be 0.001. Okay? Because basically, only 10% pass from one to the next. Okay? Any questions on that? Now, since we're talking about changes, we're basically going to talk about these pollutants, these different things that we put into the system. Okay? So, I have my field, my cornfield, and I don't want any of pests eating it or messing with it. So I'm going to put some, basically, pesticide. So I'll put some pesticide in there. Does that pesticide usually affect the plants?
No.
It affects them positively because it doesn't let organisms eat it, right? So it doesn't affect that corn or those apples or it doesn't affect it. So when I put those pollutants, this one plant takes a little bit in to make sure, or that's what I'm doing, to make sure that it doesn't get eaten, right? And this other plant takes a little bit in, and this other plant takes a little bit in. So those plants have a little bit of that pesticide in order to basically protect it from pests, correct? Alright, now, so let's say an organism comes along, say an insect, comes along and eats a little bit of those plants, okay? And they're immune, so they don't die immediately because of the pesticide. But now do they have that toxin in their bodies? Yes, right? Now, do they only eat one plant? No, they eat several things, right? So if this plant had a little bit, this plant had a little bit, this plant had a little bit, and that insect ate 3 of them, now they have 3 things. They have 3 concentrations of the toxin. So does the insect have more toxin than one plant? Yes. All right. So here comes a bird and eats. Does it only eat one insect? It eats several insects, right? But each insect has 3 times the toxin level that the other one had. So now this bird eats 3 insects, but instead of 3 times the toxin, now it has 9. 9 times the toxin. And then this bird, it goes to the swamp and is eaten by a crocodile.
Now that person.
Well, alligator, not an alligator.
Now
But it doesn't just eat that one bird, it eats 3 birds. So now it has 3 times the amount of that, right? So if you think of pollutants, as I go up this energy pyramid, are pollutants increasing or decreasing? Increasing. So basically, if I think of pollutants, it's almost like this triangle is upside down. My producers have the least amount, then it increases to my primary consumers, then it increases to my secondary, then it increases to tertiary, and so on. And the reason for it is because organisms don't just eat one of something, they eat several. So if you're eating several that has toxins, then you're increasing your toxic level. That's why they say, like, have you heard women shouldn't be eating like tuna because of mercury poisoning?
No.
Have you ever heard that? That like pregnant women really are not really supposed to be eating a lot of seafood because there's mercury in our oceans. We put it there. Okay, mercury is a poison. If they eat seafood, they should eat things that are small. If they eat things that are small, then they're not getting a lot of it. Now, they still shouldn't be eating a lot of it. Now, if you eat fish that are bigger, if you eat just one fish that is bigger, you're still getting a higher level of toxins. So you're up here. Okay? So, one of the things that they say to pregnant women is that you need to be very careful with seafood just because of that mercury poisoning. And the reason for it is because as you go up this triangle, you have more and more of toxic levels. Okay? So, any questions over that? So, overall, for these notes, you need to understand that long-term changes are caused by who? Us. Short-term changes are caused by who? Nature. Okay. What happens to energy as it goes up the pyramid? Energy decreases, right? What happens to pollutants or toxic levels as it goes up the energy pyramid? It increases. Those are the major points. Question? We don't do it on purpose. It's factories that basically put stuff in the ocean. Anytime you put any type of trash, if you put trash that has mercury, remember we talked about it basically just gets buried, water goes down, it gets flowed, it flows into the ocean. So a lot of the mercury has been put in there by us, not necessarily just our factories, but by us throwing away things that we shouldn't be throwing away. That's why I tell you, it's like, don't throw away those batteries. Batteries need to be recycled because some of those chemicals are getting into the oceans. Okay? Any questions?
No question.